Hello everyone. So yesterday we have started already the projectile motion. So if you like that video, please share and subscribe and comment it. And if any mistake, also comment. So please share the channel, please share the video so that it will be helpful to all others. Okay. So what we started yesterday? So we started yesterday about the projectile motion first case and the equation of motions. So what are the equation of motion? So the equation of motion motions are S equal to ut plus half at square, v equal to u plus at, v equal to u plus at, and your v square minus u square equal to 2as. Okay, so what is S? S is the distance, u is the initial velocity, v is the final velocity, and a is your acceleration. And remember, in the projectile motion, at a height, that means at the vertical side, your ax is 0, right? And your ay will be plus g or that be minus g. That means if we are considering ay j cap, that means okay, so this is I cap and this is your j cap. Okay, so if we are considering the j cap, that means it moving to upward. If you are considering j cap, that means moving to upward, then your ay will be minus g j cap. If it is downward, right, it is upward, and if it is downward, okay, if it is ay minus j cap, that means if it is moving to downward, then this will be g j cap. Okay, so the magnitude will be positive if it is moving downward, and the magnitude will be negative it is moving upward. So upward direction your acceleration will be negative, and downward direction your acceleration will be positive. So this is downward and this is upward. So remember, these are the special things. And what other things we have studied, that if this is your velocity, that is the initial velocity or final velocity, then what is the x component velocity? If this is the theta, theta is the angle that make with the horizontal. Okay, so this is your horizontal and this is your vertical. This is horizontal and this is vertical, so that will be u cos theta and your vertical will be u sin theta. So these are the velocity component. Velocity component. So we also started from these things, that if this is u and this is theta, then that will be your u cos theta and that will be your u sin theta. Since theta is a variable here, so your u cos theta and u sin theta will be different, right? So these are the velocity component. Then what we discussed in case 1. In case 1, we have discussed that the object is launched from the ground, it reaches to a maximum height and it passes a range horizontally. So this is your vertical, right? So this is your horizontal. So this is vertical and horizontal, the range, and this is the height, and this is the angle made with theta. So at a particular point, your velocity direction is this one. Your velocity direction is this one. So this is u, this is u, this is u. And if you are considering the x or y component, then that will be this angle if alpha, then this will be u cos alpha, and that one will be u sin alpha. Right? At each point, your horizontal will be u cos theta and vertical will be u sin theta. Since the theta is changing, so the velocity component will also change, right? So remember this thing, that is the horizontal. So what will be the horizontal here? So this is the horizontal, this is the vertical, and this angle is your alpha. Then this will be u cos alpha and that will be u sin alpha. So these are the velocity components at particular point, right? Then we have started to find out the horizontal distance at a particular point. So in the previous class, that is in the first case of projectile motion, So what we have discussed that our range will be, that is the maximum range when this will be this is the angle theta that made with the horizontal, and this is the your horizontal axis, and this is the vertical axis, and object is fire with velocity u. Then what we got the range? So the range we got as u square sin 2 theta divided by g. So our R maximum, what is our R maximum? That is u square divided by g. Then what we got in your maximum height case? So in the maximum height we get, so u square sin square theta divided by 2g, right? U square sin square theta divided by 2g, and our h maximum we get u square by 2g. And the total time of height we have taken, that is 2u sin theta divided by g. So what is the total time of height? This is nothing but t1 plus t2. So this is the maximum height, and this is the O point and A point, then B point. Then to move to O to A, the time taken was t1, and from move to A to B, the time taken is t2. And physics says if there is no air resistance, air resistance, then your t1 equal to t2, right? If there is no air resistance, then t1 equal to t2. So what is the total time of flight? t1 plus t2. So that is nothing but 2u sin theta divided by g. And the maximum range, this is the maximum range, that is the horizontal path. So u square sin 2 theta divided by g, and R maximum, when this will be R maximum? If theta equal to 45 degree. So R maximum equal to u square by g. So your theta equal to 45 degree, and your maximum height is u square sin square theta divided by 2g. U square sin square theta divided by 2g, and that's h maximum equal to u square by 2g. That happen when theta equal to 90. So these are the all three formula for the case 1 of projectile motion when there is no air resistance. When there is no air resistance, we have discussed it previously. If you don't know, then go to the previous class and see what we have studied. Okay, so today we will discuss about the second case of projectile motion, that is the object is dropped from certain height h, right? Okay. So the case 2 is here, an object. So this is projectile motion chapter. Remember, there is no air resistance. This is our assumption that there is no air resistance. Okay, so what is case 2? Now an object is dropped from a certain height h. Okay, so an object is dropped from a certain height h. That means we have a wall like this. So the wall height is h, and an object is dropped from this, okay, to the downward. So what is the case? So that means आप एक वॉल के ऊपर बैठे हैं और उस वॉल से एक बॉल को ड्रॉप करते हैं, ठीक है? So the ball will move to downward. That means you can also take your wall height and your height also. So that is actually h. So we have certain height h, and the ball is dropped from certain height h. So what is the theory behind it? The theory is says that let us consider an object is fall from a certain height h, and it will move to downward, right? So you have a height h and the ball is dropping from the height h, and no force is given. In the first case, we give some initial velocity so that the ball will move to upward, then after some time, after reaching the maximum height, it will again goes to down. But in this case, the maximum height is h, right? And this is the initial height. That means this is the initial position. So this is the initial position is your h. Then the ball is dropped. The ball is just dropped. That means we are taking your ball and we are dropping it from a certain height h, right? So we will also see that how much time it will take to reach the ground. Then what is the velocity at the ground when it touches? That means the final velocity. Okay. So here again I am repeating the theory. Let us consider an object is fall or has been fall from a certain height h, right? So what is the initial height h0? This is nothing but h. What is the initial velocity? This is 0. What is u? U is your initial velocity and this is initial distance, right? So these are the things known to us. So when the ball will reach to the ground, your final velocity will be v, right? The ball is dropped, so this is initial. This is initial and this one is your final. So the ball is dropped from the height s with the initial velocity 0. That means we are just dropping, so we didn't give any initial velocity. And s0 is your h, that is your initial height, right? So what are the equation of motion? Equation of motion says that s equal to, what is the equation of motion? S equal to ut plus half at square. S equal to ut plus half at square, right? In the initial case, initially what will be happen initially? What will happen initially? Your s is nothing but, so that means initially is your s0 and these are the so initially your s equal to height, right? So initially, that means in the starting position your initially will be h and initial velocity is 0, then half into look that the particle is moving to downward. The particle is moving to downward, so your acceleration will be g, right, into t square. Or otherwise you can take sy uy ay, right? That is the y component, the equation motion with y component. So what is the y component of equation of motion? We have equation of motion s equal to ut plus half at square. Take the initial condition or the y component. So what is the y component? Sy uyt plus half ayt. Then what is the sy? What is the y? Sy. What is the distance in vertical or in the y? So this is nothing but your s, right? The initial height is s. Then what is the initial velocity? This is 0. 0 into t, so that's 0. Then half is there and ay. What is ay? The acceleration in the y direction. Since it is moving to downward, so our acceleration is positive. That means a equal to g, then into t square, right? So what will be your t? T equal to 2s by g root over. So this is nothing but the time taken. What is t? The time taken to reach to ground. तो ग्राउंड तक आने के लिए ये कितना टाइम लेता है? t equal to 2s by g root over, right? So remember, so first of all we have calculated the height, sorry, the time taken to reach the ground. So what is the formula? T equal to 2s by g. So remember what we got? T is, this is important, remember, note, T is independent of mass. Right, look to the expression on which T is depending. T is depending on h square root because g is constant, 2 is constant. So a time taken to reach an object from a certain height h, if it is dropped without any air resistance, then the time taken to reach the ground depend upon the height only. So it does not depend upon the mass. So if you are dropping at a same time, if you are dropping a chalk or any stone, big stone or small stone, all will take same time to reach the ground. Remember, the time does not depend upon the mass. So how large it is, how mass large it is, it does not depend. It is depend upon the height. Okay, so if you are dropping a small mass object and a big mass object at same time, the time taken from the same height, the time taken to reach the ground also same. So remember, आप एक बड़ा ऑब्जेक्ट ले जाइए या छोटा ऑब्जेक्ट ले जाइए, तो दोनों अगर हम सिमिलर हाइट से ड्रॉप करेंगे तो सेम टाइम लेंगे ग्राउंड में रीच करने के लिए, ठीक है. So it will take same time to reach the ground. It does not depend upon the size or depend upon the mass. Also not size. It is independent of size and mass. Okay. So volume और area के ऊपर भी नहीं डिपेंड करता है, ठीक है. So this is the first case. How much time it will take to reach the ground? So what is the second case? The second case we will discuss that what is the final velocity. So remember, this is the second case. So what will be the final velocity? What is the expression of v? So what is v? Remember, we have equation of motion. Again, we have equation of motion. Okay, write the theory. We have to write some dialogue here, then we will start the mathematical part. So what is the dialogue? Let us consider an object having mass small m, any mass. Okay, let us consider an object having mass small m is fall down from a certain height h. Let u be the initial velocity, which is 0 here, and the initial height is h. So these are the things you have to write, mention what are s0, what are u, what is h. So this is the initial height, that means initial vertical distance, right? So write the dialogue here, then start the mathematical part. This will be your note. If you want to provide note, then there is a comment in the comment section. I will provide you the note, right? So the note is nothing, the dialogue, the theory part is nothing. Whatever you are seeing here, that right here, that will be your dialogue. So let us consider a small mass m that is fall down from a certain height h, and let u be the initial velocity, which is 0, and s0 is your initial height. Then your acceleration is plus g if it is moving upward, and the acceleration is minus g, it is moving upward. If it is moving to downward, then that will be plus g. Okay, so we have equation of motion. What is the equation of motion? We will use here to find out the final velocity. So remember, we have v equal to u plus at, right? V equal to u plus et. So write the y component. Does not matter what is the y component. Okay, so v equal to your initial velocity is 0, and acceleration due to gravity is your g, and it is t. So this is moving to downward. So your acceleration, initial velocity 0, acceleration is g. That means v equal to g into t. So what is the expression of t? We have find. So g is t equal to 2h by g root over, right? So this is g into 2h by g root over. Okay, so this is g, right? So g means g equal to square root of g into square root of g. We know this from mathematics, that g equal to the multiplication of 2 square root of g. That means 1 square root of g and second square root of g. If we multiply them, then we will get the g. So यहाँ पे जो g है, that means यहाँ पे 2 square root g है. So 1 square root g will be cut from the denominator. यहाँ पे एक g है, लेकिन square root है, ठीक? So there is a square root in the g, that is in the denominator, and there are 2 square root g. So 1 square root g will be over. So 1 square root g into square root 2h. So what is the final velocity? Since this is the power is same, so it will move to what? So v equal to 2gh root over. So remember this. So what is the final velocity? Okay, write it 2gh. That will be easy to remember. So what is the final velocity? The final velocity is 2gh square root of 2gh. So with what velocity it will hit the ground? This is the answer. if a height is given to you and an object mass also given to you, then how much time it will take? 2h by 0 to reach the ground. Then when it reach the ground, with what velocity it will touch the ground, कितना वेलोसिटी में वो नीचे स्ट्राइक करेगा, मतलब नीचे हिट करेगा. So what is the velocity? 2gh root over. Remember here also velocity does not depend upon the mass. The velocity depend upon the h. So how much large the object would be, that does not matter. How much large the object, that does not matter. It is depend upon with what height it is dropping. If maximum height is dropping, then it will take maximum time, and the velocity to hit the ground also maximum. Initial velocity 0, but final velocity is 2gh root over. So this is the velocity. The second thing, with what velocity it will reach the ground, the answer is 2gh root over. Okay. So this is the second part of the projectile motion. So these are all things about the second case, and one more case, that is your third case about the projectile motion. Right. So what is the third case? The third case is also similar, but just add the first case and second case, you will get the third case. So third case is nothing but the ball will hit with some initial velocity from a certain height h. Okay, an object. So what is the third case? An object, it is projected, not dropped, projected. This is the third case. An object is projected from a certain height h with some initial velocity. The object will projected from a certain height h with initial velocity. So this is one application of the launching of rocket. Okay, so when we are launching a rocket, we have given some initial velocity from certain height h, then it will move to upward, and after reaching the maximum height it will fall down. Right. What is the diagram? We have some height h, and this is the ground. This is the ground, that is the horizontal. Okay, this is the horizontal, the ground, and an object is fired. An object is fired from certain height h with some initial velocity u. So it will move to some height, then it will fall down. Right. So this is the case. It will move to certain height, then it will be fall down. So this height is given to you h, and some initial velocity will be given to u, and the ball will fire. This is horizontal, right? Some angle theta. This is also horizontal. So it will reach some maximum height. So okay, let this is the small h and this is the capital H. This is the horizontal. Okay, this is the horizontal, that is your x-axis, and this is the height. Right. So this is the range. That means the horizontal distance. This is the height, this is the initial velocity. So what will be the diagram? So look here, let us consider an object having some mass small m is fired from certain height h with some initial velocity u, full stop. So what is the initial height? So the initial height is h and the initial velocity is u. Let capital R be the range of the horizontal distance travelled by the object, and let capital H be the maximum height obtained by the object. I am again repeating. Let us consider an object having some mass small m is fired from a certain height h with some initial velocity u, full stop. Let theta be the angle with which the object fire with the horizontal. Let full stop. Let capital R be the horizontal range travelled by the object. Let capital H be the maximum height obtained by the object. Khatam? Okay, so these are the theory part. Then we will go to the mathematical part. That means we have to find how much time it will take. So same case here also. Right. What is the total time of flight? So to calculate the total time of flight, let I am again considering that we have some initial velocity and theta is the angle making with the horizontal. So the horizontal component will be u cos theta and your vertical component will be u sin theta. Right? Remember the initial height is small h and the maximum height is capital H and r is your horizontal distance. So what is the equation of motion we have? Equation of motion is s equal to ut plus half at square. We want to calculate what is the total time of flight for the case that the object is fired or projected from a certain height h with some initial velocity u. Okay, so the ball is fired to upward. Then after reaching the certain some height h, then it will move to downward. If we consider the case that sy, it is the y component. If we write the y component, then what will be your sy? And remember that if you are writing in the upward case, it is moving to upward, then to downward, it is moving to upward, then to downward, then upward height will be minus h, and your initial, what is the uy component? So this is nothing but u sin theta into t, then minus half gt square. This is moving upward, so I have given a as minus gt square. So this is one your quadratic equation, because in this case your h is constant, theta also constant, and your g also constant, that is 9.8 or nearly equal to 10 meter per second square. 10 meter per second. So these are all constant. So your variable is only t. So this is a quadratic equation, and you know how to solve the quadratic equation. Then solve the quadratic equation, and you will get the total time of flight. Right? Okay. So you can write also this equation as take the minus half gt square to the left side, so that will be half gt square, then your minus u sin theta into t into minus h equal to 0. So this is the quadratic equation. Then how you will solve the quadratic equation? Remember, so this half gt square, okay, take the two sign, multiply with them, so that will be gt square minus 2u minus 2h, that will be 0. So what will be t? That will be minus b plus minus b square, so 4u square sin square theta plus b square minus 4ac. So that will be minus b plus minus b square minus 4ac. So that will be 8 gh root over divided by 2g. So this is the total time of flight. This is the quadratic equation. You solve the quadratic equation and you will get the total time of flight. G, theta, u, h, that will be given to you. So you can calculate the total time of flight. Right? Then what is the range? What will be the range? Again, look to the equation of motion, that is s equal to, okay, so forget about this, that is our, okay, so s equal to ut plus half at square, right? So to find out the range, that is the horizontal case, so we have to take the x component, right? We have to take the x component. So what is the sx? What is the x component? This is the range. And what is ux? That is u cos theta into t. What is ax? What is ax? So ax is nothing but 0, right? So this is the range. So what is the range? R equal to u cos theta into t. So we have calculated the total time of flight from this equation. Then use this time equation. Here you will get the maximum range. So what is the maximum range? U cos theta into t. Because we are considering the horizontal case, that will be u cos theta into t. Because your ax is 0, So substitute here, you will get the maximum range. So this is the maximum range, and how much time it will take to reach the ground. That means how much time it will take to reach here. So these are the all cases. Okay. So on this, from these two equations, also you can calculate that what is the final velocity. From these two equations also you can calculate what is the final velocity. That means what will be your v. We know that v equal to u plus at, right? So you have calculated already t value. Then you can take any, that is your x component or y component. So if you are taking the vy, then that will be uy plus ay into t. So what is your vy? So vy is your final velocity. So that means your final velocity. So it is moving to downward. So that will be vy. So your final velocity uy. Uy is nothing but u sin theta, and ay is minus dt. Right. So this is the final velocity equation. So all will be derived from the equation of motion. That is the three equation of motion. V equal to u plus at, s equal to ut plus half at square. But remember, when you are writing the xy component, look that you are moving or down, or moving upward or downward. Then if you are moving to upward, your height will be minus h and your acceleration will be minus g. If you are moving to downward, your height will be h and acceleration will be g. So this is the final velocity and the time taken to reach the ground. Then what is the maximum range, that is how much it will travel. So these are the all things about the third case of the projectile motion. Right. So we have calculated the range, the time taken. Then we can also calculate the maximum height. What will be the maximum height? What is the h expression? We know that h. So this is h and this is y. Right. So actually this is h. So this one is your capital H and this one is your y. This one. This is y. So what is capital H? A capital H equal to, so this is the height, maximum height. What is capital H? So maximum height is capital H, and this is small h, that is the height of the wall, and this is the y. If you look to the case, that is O2A. So what is O2A? This is O2A. That is our first case of projectile motion. So what is the maximum height? This is y. We know that y equal to, what is y? So u square sin square theta divided by 2g. Right. So this is the maximum height. Because we know here what is y? Y equal to u square sin square theta divided by 2g. That we have discussed in the yesterday class. So this is the first case of projectile motion, that if a particle is fired from ground, then what is the maximum height? U square sin square theta by 2g. So this is the maximum height y, that will be u square sin square theta by 2g. Just add them, you will get the maximum height. So we have calculated the time taken from the quadratic equation, then the maximum height and the maximum range and the final velocity. So this is all about your projectile motion. So try to remember, and if any mistake, please comment in the comment section, and also share this to all, that will be helpful. Okay, thank you. Jai Jagannath.